This video discusses exploring categorical data, specifically frequency tables. So the first thing we're going to talk about is marginal frequencies and distributions. So qualitative data encompasses two categorical variables that may or may not have a dependent relationship. And so these data can be displayed in a two-way contingency table, which most of the time we just call a two-way table. And so basically you'll have two categories that you are looking at that may or may not have a relationship. All right, so an example 5.1, the cuteness factor. A Japanese study had volunteers look at pictures of cute baby animals, adult animals, or tasty-looking foods, after which they had their basically their focus tested in solving puzzles. And so in your table, you can see that you have your each type of picture that was viewed, and then the level of focus that was exhibited by a certain number of people. So people that looked at baby animals, you had 5 people that had low focus, 20 people that had medium focus, and 40 that had high. For adult animals, 30 had low, 40 had medium, and 15 had high. And for tasty foods, 55 had low, 35 had medium, and 10 had high. Pictures viewed is the row variable, whereas the level of focus is the column variable. So remember, rows go left to right, columns go up and down. One method of analyzing these data involves calculating the totals for each row and each column, which is what you see below. So now we have the same exact table, but this time we've added an extra column that gives you each of the row totals. So there were 65 total people who viewed baby animals, there were 85 total people who viewed adult animals, and there were 100 people who viewed tasty foods. Altogether, there were 250 people that participated in this particular study. So then you've also got your column totals. So there were 90 people who had low level of focus, 95 who had a medium level of focus, and 65 who had a high level of focus. These totals are placed in the right and bottom margins of the table, which is why we call them marginal frequencies or marginal totals. These marginal frequencies can then be put into the form of proportions or percentages, and so the marginal distribution of the level of focus would be those that had low focus. There were 90 who had low focus out of the total 250, and so 90 of 250 would give us a proportion of 0.36 or 36%. Medium focus, there were 95 people who had medium focus out of 250, and so that would give us 0.38 or 38%. And then there were 65 out of 250 who had high focus, and that would be 0.26 or 26%. We can also display this distribution in a bar graph. And so if we were doing a bar graph, we would make our y-axis and our x-axis. Remember that you need to always label. So this would be level of focus across the bottom. And these would be your categories. So your low, your medium, and your high. And then the y would be our percentages. So we would maybe do like 10%, 20%, 30%, and then 40%. So for our low, we had 36, and so we would go just a little bit above, a tiny bit above, halfway between 30 and 40. Remember, in a bar graph, our bars do not meet. Medium was at 38%. And then high was at 26%. Similarly, we can determine the marginal distribution for the pictures viewed. And so if you go back to the table, that would be for baby animals, you had 65 of 250. For adult animals, you had 85 of 250. And for tasty foods, you had 100. out of 250. So for baby animals, 65 of 250 would be 0.26 or 26%. Adult animals was 85 of 250 or 0.34, 34%. For tasty foods, you had 100 of 250, which is 0.40 or 40%. And so you could also make a bar graph for this one. So this time, our x-axis would be labeled as pictures viewed. And so you would have your baby animals, you'd have your adult animals, and then you'd have your tasty food. Percentages on the sides. Baby animals was 26%. Adult animals was 34%. And tasty foods was 40%. Conditional frequencies and distributions. So the marginal distributions described and calculated in the last examples do not describe or measure the relationship between two of the categorical variables. We were only looking like specifically just at adult animals or specifically just at people that had medium levels of focus. We weren't looking for people that had medium levels of focus and looked at adult animal pictures. So when we look at conditional frequencies, those are like when we combine information. So in order to be able to consider the information in the table, you're going to have to look not just at the sums and the margins, but you're really going to have to look at the whole entire thing. So in example 5.2, we're interested in predicting the level of focus for the pictures viewed, and so we look at the conditional frequencies for each row separately. For example, in 5.1, what proportion or percentage of the participants who viewed baby animals then had each level of focus? So we're looking specifically at people who viewed baby animals and the level of focus that they had. So there were, if I go back to this table, there were 5 people who had low level of focus and looked at baby animals, out of a total of 65 people who looked at just baby animals. So we're looking for level of focus over the number of people who looked at baby animals. So 65 was the number of people that looked at baby animals, and there were 5 people who had low level of focus. So 5 over 65 would give you 0.077 or 7.7%. Now we're going to look at people that had medium level of focus that looked at pictures of baby animals. So there were 20 people out of 65 people that had medium level of focus and looked at baby animals. So 20 out of 65 will give you 0.308 or 30.8%. The last is going to be high, so we're going to go back, look at the table. There were 40 people who had high level of focus, 40 out of 65 that looked at baby animals. So 40 over 65 will give us 0.615 or 61.5%. This conditional distribution can be displayed either with groupings of bars or by segmented bar charts where each segment has a length corresponding to its relative frequency. So let's first do one that's just the bars. Levels of focus after viewing baby animals. So we're going to put this here because it's going to work for both of the bars, both of the charts that we're working on. So this first bar, or the first chart that we're going to do, would be most helpful probably if you were doing like the conditional probability for each of the types of pictures that were viewed, and you were kind of like grouping together like those people that had low, or the people that looked at baby animals. So it would be like, so I'm going to go over to the side and make a key. So if it's colored in, then this is going to be high. If it's just open, this is going to be medium. And then we'll do like, if it has stripes, this is low. Okay, so there was 7.7% that was low. There was 30.8% that was medium. And there was 61.5% that was high. Okay, a segmented would look kind of like this. So we'd have our 20%, 40, 60, and so there's our low. Oh. So if the bottom was 7.7 and we needed the next piece to represent 30.8%, then you would think about like basically altogether the entire height of this thing should be 7.7 plus 30.8. So roughly like 38 in a piece. Okay. The top should be the high. So now we're going to add to that roughly 38, a 61.5%. And so that should get us to 100%. Okay. Now, again, this would be like, that entire bar would be like 61.5% plus 30.8% plus 7.7%. So you can see it gets you to 100. The height of the bottom piece, this piece, and this piece would be the 30.8 plus 7.7. So 38.5. Similarly, the conditional distribution for the participants who viewed adult animals are. So we're going to do the same thing for adult animals. So if you go back to our table that had our totals on it, we're looking at adult animals. So each one of these levels is going to be over 85. And so for low level of focus, there would have been 30 out of 85. For medium, there would be 40 out of 85. And for high, there would be 15 out of 85. So we're going to do the same thing here. For medium, we had 40 out of 85. And for high, we had 15 out of 85. You can do the same thing for tasty foods. So we're going to go back. Our tasty foods is all going to be out of 100 because there were 100 people that were given pictures of tasty food. 55 of that 100 had low levels of focus, 35 had medium level of focus, and 10 had high. So now we're going to do the exact same thing here. We're going to say 55 out of 100. 0.55, 55%. For medium, we would have 35 out of 100. 0.35 or 35%. And high, we had 10 out of 100. 0.10 or 10%. Okay, so now we're going to put it all together, and we're going to do bar charts that have groups for each of the types, and then we're going to do a segmented bar chart or bar graph that has all of the groups on it as well. All right, so we're going to start with making sure we label our x-axis. So this is going to be our pictures viewed. So we got to have our 3 types of pictures that were viewed. So you had your baby animals, you had your adult animals, and then you had your tasty food. So we'll do 20. So remember, you gotta have your key. It's gonna be high, medium, low. Okay, so we're gonna put together kind of the picture that we had in the first bar chart that we did earlier, and we're gonna add to it the adult and the tasty food. All right, so we would have low, and this is gonna be small. I don't have a ton of room. Medium. And then the high. And these numbers are coming from where we did this earlier. Okay, adult animal pictures. So these are coming from these numbers. So 35.5% for low. 47.1 for medium, and 17.6% for high. All right, tasty foods, these are coming from these numbers. So 55% had low. 35% had medium, and 10% had high. Okay, then we're going to do the same thing with a segmented bar chart. This is all the exact same information. It's just done in a different way. Done in a different type of representation. Okay, for adult animals with low focus, they had 35.3%. So the bottom piece is going to be here. Then they had 47.1%, so 47.1% plus that 35.3% is going to put you past 80%. And then plus the 17.6% should take you to 100. Tasty foods, the low was 55. The medium was 35, so that'll get you to 90. And then you had 10% at the very top. All right, example 5.3. A study was made to compare year in high school with preference for vanilla or chocolate ice cream with the following results. So you had your freshman, sophomore, junior, and senior class, or people in those classes. You had your vanilla and your chocolate. All right, what conditional relative frequencies for each class, or what are the conditional relative frequencies for each class? So the first thing you need to be able to find conditional relative frequencies is to get all of your totals. So there were 30 total freshmen that were asked. That comes from 20 plus 10. There were 36 sophomores that were asked, 24 plus 12. There were 27 juniors that were asked, 18 plus 9. And there were 33 seniors that were asked. Now, these are really the only numbers that we need because we're being asked to give the conditional relative frequency for each class. So we just need to know how many from each class were asked. All right, so freshmen that prefer vanilla. So for the freshmen that prefer vanilla, there were 30 total freshmen that were asked, and 20 of them preferred vanilla. So 20 over 30 would give you let me go over. Let me write this a little closer so I've got room. So you've got 20 out of 30 that were asked. That's going to give you 0.667 or 66.7% that prefer vanilla. Freshmen that prefer chocolate. Okay, so there were 10 out of 30 that prefer chocolate, so that'll give you 0.333. And I'm going to leave these as decimals. All right, sophomores that prefer vanilla. So there were 36 sophomores that were asked. There were 24 that preferred vanilla. So 24 over 36 will give you 0.667. Sophomores that prefer chocolate. So there were 36 sophomores that were asked. 12 of them prefer chocolate. So 0.333. Juniors, there were 27 juniors that were asked. Of the 27, 18 preferred vanilla, and so that's 0.667. For the juniors that prefer chocolate, there were 27 that were asked. 9 preferred chocolate, and so that would be 0.333. For the seniors, there were 33 seniors who were asked. There were 22 that preferred chocolate, so 22 out of 33 will give you 0.667, or that preferred vanilla. And then for the seniors, there were 33 that were asked. There were 11 that preferred chocolate, so that's 0.333. All right, so if you'll notice, the same proportion preferred vanilla for each class, the same proportion preferred chocolate for each class. So in such a case where all the conditional relative frequency distributions are identical, we would say that these two variables show perfect independence. However, you should note that even though the two variables are completely independent, the chance is very slim that you would have a resulting contingency table that will show perfect independence. All right, 5.4. Suppose that you need a heart surgeon and are trying to decide between two surgeons, Dr. Fixit and Dr. Patch. You find out that each operated 250 times last year with the following results. So you've got Dr. Fixit, Dr. Patch, you've got your number that died and your number that survived. So Dr. Fixit had 60 patients that died, 190 who survived. Dr. Patch had 50 patients that died, 200 that survived. So the question is, whom should you go to? So among Dr. Fixit's 250 patients, 190 survived for a survival rate of 190 out of 250, which gives you 0.76 or 76% that survived. While among Dr. Patch's 250 patients, 200 survived. So 200 out of 250 gives you 0.80 or 80%. So it seems like your choice is pretty clear. However, everything may not be so clear-cut. Suppose that on further investigation, you determine that the surgeons operated on patients who were either in good or poor condition with the following results. So we've got two different tables. One for people who were in pretty generally good health when they were operated on, and then the second table is for people that were in maybe not so good health. So you still got your Dr. Fixit, your Dr. Patch, those that died, those that survived in both of the tables. So how do the surgeons compare when operating on patients with good health? So Dr. Fixit had 68 patients in good condition with a survival rate of 60 out of 68, which is 0.882 or 88.2%. Okay, Dr. Patch had 137 patients in good health, and he had 120 who survived. So he has a survival rate of 120 over 137, which is 0.876 or 87.6%. Dr. Fixit's patients in poor condition, so he had 182 patients in poor condition, and 130 of them survived, so 130 out of 182 gives you 0.714 or 71.4%. Dr. Patch had 113 patients and had a survival rate of 80 out of 113, which is 0.708 or 70.8%. So if you're comparing those that are in good health, it looks like Dr. Fixit does better with patients in good condition, and so that's because he has a survival rate of 88.2% versus Dr. Patch's survival rate of 87.6% with good patients in good health. And so he also does better with patients in poor health too, because he had a survival rate, Dr. Fixit did, of 71.4% versus Dr. Patch's 70.8%. However, Dr. Fixit has an overall a lower overall patient survival rate if you go back to what we did to begin with. So remember, Dr. Fixit had a lower survival rate when we were first looking at our table because he only had 76% that survived. However, we're looking at it now and we're able to see it kind of broken down, and we see that Dr. Fixit does better with patients that are in good condition and with patients that are in poor condition. So how does that work? So this is Dr. Fixit's overall patient survival rate was 76 versus Dr. Patch, whose survival rate was 80%. So how is this even possible? So if this is possible by something that we call Simpson's paradox. And so that's where a comparison can be reversed when more than one group is combined to form a single group. So in this case, we broke it down into patients in good health and patients in bad health. The effect of one variable, sometimes called a lurking variable, is masked when the groups are combined. So when we're looking at just the overall, it's kind of hidden in there. In this particular example, closer scrutiny reveals that Dr. Fixit operates on many more patients in poor condition than Dr. Patch does. So if we go back and we look, Dr. Fixit was operating on 182 patients in poor condition, while Dr. Patch was only working on 113. And so these patients in poor condition are precisely the ones with a lower survival rate. So even though Dr. Fixit does better with all patients, his overall rating is lower. Our original table hid the fact of the lurking variable related to the condition of the patients. So again, we were not able to see that even though Dr. Fixit has a lower survival rate, it's because he's operating on more patients.